Okay, now we are looking at neural networks. Now, neural networks comes from the same idea of neurons as the brain. The brain also has neurons, and we are trying to use the same idea. Now, neurons are like the thing in the brain, and they get activated and deactivated and pass on the electricity. Now, we use electricity to transmit signals. That's how brain transfers signal from one place to the other, and for that we use something called TensorFlow. TensorFlow is a library or a package that is used for machine learning, and it is a package that is used everywhere, that talks with GPU, CPU, Android, iOS. The front end could be built up in Python, C++, any language that we want. Now, if you see this chart, you see that you have an estimator, then you have an estimator and Keras. Keras is a wrapper around TensorFlow, which means that it's an abstraction layer, a more front end. By front end, I mean that, for example, if in the future we want to talk to a robot, we need to talk to a robot using a programming language, the front end, if something goes bad, to handle it programmatically if that feature is not available. So to do that, we need to use a general purpose simple programming language like Python. So Python front end can help to talk TensorFlow, but Keras is another abstraction layer to make our neural network modeling very easy. So Keras is a wrapper. On the back end, it always works with TensorFlow. So whenever you get an error, it's because of the version mismatch between Keras and TensorFlow and Python. So these are the neural network, and this is for the iris classification. We have been using iris classification all the time for running everything, and we are going to do the same in our hands-on practice. Now if you see here, we have sepal length, sepal width, petal length, and petal width. This has been all the time. Now what you see, the arrows are weights. So whatever is the input, we multiply it by 0.4, and then we take a tanh, a transform, and I'm going to show you a transform which is based on the perceptron that we are using. Then we multiply the weight again, and then we have two layers. Once we have the two layers, we give up an outcome which has only three things. Our outcome is that iris S, iris V, and iris V, whether it's virginica, versicolor, or septosa. So this is how it would work. We have 4 input, 3 output, and layer, and this is called forward propagation. Again, the same idea. We have 3 inputs, 2 outputs. If it's 2 output, it could be a classification problem. It's more than 2 output, it could be a regression problem, and just 1 layer. And the math of the excitation is based on 10 or logit, whatever we may want to call it. So in other simple words, we have a lot of neuron and activation function. Input layer, hidden layer, and output layer. Most of the time in image processing, to detect whether it's a cat or a dog, or to find out image, we use neural network. So we have input and we have weights. Weights were the thing that were attached on the top. So these are the weights, or everything on the top, 0.01, 0.02, 0.03, 0.04. So these are the weights. So one get multiplied by that. Once that happens, we use a function transfer, and we use an activation function. This activation function could be a lot based on what we want to do. So these are the list of all the kind of neural networks that exist, like recurrent, long-term, short-term memory, gated recurrent, deep forward, radial basis, feed forward, perceptron, autoencoder, variation, denoising, and sparse. These are all the way in which we can make these networks and layers. This is a very quick introduction about neural network, just to get a familiarity of what they are.